another important chapter is there from physical pharmacy, known as a rheology. Every year from this chapter they used to ask question. Every year, believe me, this chapter is very important. Every year they used to ask at least one or two questions from this chapter, rheology. So rheology is very important chapter from physical pharmacy. In the last lecture, I have already told you how many chapters are important, like your micrometrics, rheology, chemical kinetics, phase rule, chemical kinetics, phase rule, then colloids, surface tension, interfacial phenomena, then your colligative properties, etc. etc. So all these chapters are very important. Out of that also, so we'll see it one by one. So first, what do you mean by rheology? The term rheology. What do you mean by rheology? So it is nothing but the flow of science, okay, study of flow. Now rheology. So if you take a water in a glass bottle and if you try to pour, it is easily pouring. If you take a oil in a bottle and if you try to pour it, so it will also pour, but it will take a time. In same bottle, you take a glycerin, then you try to pour, so it will take a long time. So every liquid or every substance will flow differently. Now rheology is the study of flow. Rheo is the one of the okay. Rheology is based. It is rheology is derived from two words. Rheo. First one is rheo. Rheo means flow. It is a Greek word. Okay. Then logos. Logos is also Greek word, means science. So it is a study. Simply, it is a rheology is nothing but the study of flow or science of flow of material or body. Now this rheology term was suggested by this Bingham and Crawford. Bingham and Crawford, they suggested this term rheology. Rheo means flow and logos means science. So rheology is nothing but the study of flow of body. Okay. Now every material or every body will not flow. Okay. So as far as solid body is concerned or solids are concerned, solids they are deformed. Okay. If you apply stress, if you apply फोर्स ऑन द सॉलिड, अगर आपके पास में कोई सॉलिड मटेरियल है उसके ऊपर आपने फोर्स अप्लाई किया तो एक तो क्या होगा, वो टूट जाएगा, डिफॉर्म. देयर इज अ डिफॉर्मेशन ऑफ सॉलिड आफ्टर एप्लीकेशन ऑफ फोर्स. नाउ दैट डिफॉर्मेशन में भी इधर प्लास्टिक और है ना इलास्टिक. सो प्लास्टिक और इलास्टिक डिफॉर्मेशन, दैट इज गवर्न्ड बाय अगेन द हुक्स लॉ. देयर इज अ वन लॉ नोन एज द हुक्स लॉ. सो दैट गवर्न्स elastic deformation of solid particle. Okay, that is another part, but you should know Ohm's law is related with the particle deformation. Solids, if you apply stress on solid, if you apply force on solid के अगर आपने उसके ऊपर फोर्स अप्लाई किया, जैसे मान लीजिए आपके पास एक मिट्टी का पत्थर है, उसके ऊपर आपने फोर्स अप्लाई किया तो ऑब्वियसली टूट जाएगा वो. सो दैट इज डिफॉर्मेशन. और डिफॉर्मेशन में भी इधर प्लास्टिक और इलास्टिक. प्लास्टिक मतलब क्या, एक बार टूट गए तो टूट गए, फिर से ज्वाइन नहीं होगा. इलास्टिक मतलब क्या है, फोर्स अप्लाई किया आपने, उसका डिफॉर्मेशन हो गया, आपने फोर्स निकाल लिया, डिफॉर्मेशन वापस हो गया, मतलब वापस रिफॉर्मेशन हो गया. सो लाइक योर रबर, इफ यू स्ट्रेच द रबर, इफ यू आर अप्लाइंग फोर्स टू रबर इट विल स्ट्रेच, इफ यू रिलीज द फोर्स इट विल अगेन regain its position. So that is elastic. So material may be either plastic or elastic. So for the solid it is a deformation. Now for the liquid, if you apply a certain force or stress, so what will happen, liquid will try to flow, you know. If you apply a certain force, like वाटर है आपके पास में, वाटर को अगर आपने पंपिंग किया तो वाटर फ्लो होता है. वाटर को अगर आपने ऊंचे से नीचे गिरा देता हो, वाटर नीचे फ्लो क्यों, because of the gravity. So flow is related with the liquid and fluid. Okay, and deformation is related with the solid. No, now every liquid will not flow in the same way, so that depends on the viscosity of that liquid. Now what do you mean by viscosity? So viscosity is nothing but it is a resistant to flow. It is a resistant, so resistance to flow. So depend upon the interparticular interaction and bonding. So if there is a strong bond between interparticle, if there is a strong bond between the particles of the material or particles of the fluid or liquid, so it will not flow easily. Okay. Now viscosity, or it is also known as the dynamic viscosity or absolute viscosity. Dynamic viscosity or absolute viscosity. viscosity or dynamic viscosity or absolute viscosity is nothing but resistant to the flow. What is the unit of viscosity? Unit होता है इसका poise. SI unit of viscosity is nothing but the poise. POISE. Because it was invented by Poiseuille. Viscosity का unit होता है poise. It is the initial for Poiseuille's equation. It was given by Poiseuille. So viscosity is nothing but the resistant to the flow of fluid or liquid. Now it is defined as the viscosity may be defined as the shearing force or force required to produce a velocity, or to produce a flow. Force required to produce a velocity or force required to produce a flow of 1 centimeter per second. So force required to produce a velocity of 1 centimeter per second between two parallel plane of liquid in 1 centimeter square area separated by a distance of 1 centimeter. मतलब क्या सिंपल लैंग्वेज में बोलता हूँ. So liquid is considered as a made up from a different layer. Liquid is considered as a made from a different layer. जैसे मान लीजिए एक liquid का है ये, so it is made up from a different layer. Now if you apply a force over here, liquid is made or liquid body or liquid material is made from a different planes. Okay, जैसे इसको A B C D बोल दो. Now these planes. Okay, now if you in between these planes there is a distance. Okay, there is distance. Say for example dr. Now if you apply stress over here, if you apply force, what will happen? So this liquid will begin to flow. If you apply a force on liquid, it will begin to flow. आपने अगर लिक्विड के ऊपर फोर्स अप्लाई किया तो वो लिक्विड फ्लो होना चालू होगा. लेकिन कैसे? Okay, so initially this plane will be shifted to there. Likewise कुछ ऐसा स्ट्रक्चर बनेगा. So first plane will experience the stress or force and that will there will be change in the distance. So मान लीजिए पहले डिस्टेंस ये था, यहाँ से था, अभी चेंज हो गया. So change in the distance, that is nothing but the velocity. Change in the distance with respect to time is nothing but the velocity. So what is viscosity? It is a shearing force required to produce a velocity of 1 centimeter per second between two parallel plane of liquid having 1 centimeter square surface area and separated by a distance of 1 centimeter. That is nothing but the viscosity. And the science of flow of fluid or liquid, that is nothing but the rheology. Okay, rho means flow, logos means science, and that was suggested by Bingham and Crawford. Viscosity, or simply viscosity, is known as a dynamic viscosity or absolute viscosity. Nothing but the resistant to flow. In simple language, it is a resistant. Whatever resistance is offered for the flow of liquid, that is nothing but the viscosity. And viscosity, that is a function of viscosity. Shearing force required to produce velocity of 1 centimeter per second between two parallel planes liquid. Parallel plane of liquid having surface area 1 centimeter square separated by distance of 1 centimeter. Now kinematic viscosity. What do you mean by kinematic viscosity? So ये जो viscosity normal होता है, dynamic viscosity और absolute viscosity. So its unit is nothing but the poise. है ना? SI unit of viscosity is nothing but the poise. Now it may be either poise or centipoise, CP, centipoise or CP. उसको अपन CP बोलते हैं, centipoise और CP. 1 centipoise is equal to 10 raised to minus 2 poise, है ना? Poise अगर है उसका centipoise में करना है तो -2 into 10 raised to -2. Now why this poise is there? Why this is a poise in viscosity as a unit of poise? Why? Because this is derived from the Poiseuille's equation. Okay, so that's why poise or centipoise. Now viscosity of water. Anybody know what is the viscosity of water? मालूम है किसी को कितना होता है वाटर का viscosity? Yes, anybody? What is the viscosity of water? Do you know? So it is you can say approximately 1 centipoise, 1 cp, 1 cp. Now you know the viscosity of water. So viscosity of water is known 1 cp. In comparison with that, other viscosity of other fluid or liquid is determined. Okay, now what do you mean by kinematic viscosity? Kinematic viscosity, the kinematic viscosity as a unit of Stokes. It is again a ratio of absolute viscosity to the density of fluid. Viscosity जितना है इसको absolute viscosity और जो भी आपका dynamic viscosity है. So viscosity is generated by one term known as a eta. one term known as eta, ऐसा कुछ है ना, n टाइप का होता है. So viscosity is denoted by the term eta, EATA, eta. So that is a n. Now kinematic viscosity is nothing but the absolute viscosity divided by density. So eta divided by rho, eta divided by rho, that is a kinematic viscosity. So whatever viscosity is there, absolute viscosity, you have to divide with the density. That's it. Now what is rheology? It is related with the flow of liquid or deformation of solid. Flow of liquid or deformation of solid. Okay. Study of flow properties of solid and liquid, they are very important in the pharmaceuticals, because you are dealing with the liquid orals, you are dealing with the topical preparation like gels, ointments, cream, paste, etc. You are making syrup solutions, right? Depot preparations. So for that, rheology is very important for your pharmacy. So rheology is related with the flow of liquid and deformation of solid. The study properties of the rheology is important in the study of properties like properties of liquid, gels, ointments, cream, paste, etc. Now flow behavior of liquid, that depends on, है ना, flow कैसे होगा liquid का, that depends on the application of force or application of stress. So flow behavior of flow behavior of liquids depends on the applying stress. That is nothing but the rheology. So what will happen after application of stress to a liquid? Whether it will flow, whether it will take time to flow, whether it will not flow, whether there will be decrease in the viscosity of that liquid, whether there is increase in the viscosity of liquid, or whether there is increase in the volume of that liquid, whether there is decrease in the volume of liquid. So effect of stress or effect of application of force on the liquid, and the outcome and effect of application of force or stress on the liquid on the velocity or on the flow of liquid, that study is nothing but the rheology. Flow of liquid is quantitatively expressed as a viscosity. The flow of liquid can be expressed as a viscosity. What is it? Nothing but the resistance to, higher will be the viscosity, greater will be the resistance to flow. Less will be the viscosity, less will be the resistance to flow. And अगर किसी का विस्कोसिटी कम है तो वो जल्दी फ्लो होता है, किसी का विस्कोसिटी ज़्यादा है तो वो जल्दी फ्लो नहीं होता. So same thing. So higher the viscosity, greater will be the resistance to flow, and vice versa. For example, if you pour a water from a glass to a cup, so it is easily poured. Okay? If you try to pour a groundnut oil, honey, so that will take a time. Syrup, okay? They are a highly viscous liquid and there is the flow. Now this flow of fluid is involved in the transportation of liquid orals. जैसे आपने सस्पेंशन बनाया, सिरप बनाया, है ना, आपने लिक्विड ओरल बनाया, तो जहाँ पे मैन्युफैक्चरिंग है, मिक्सिंग वेसल है, वहाँ से आपको पैकिंग मशीन तक लेके जाना पड़ता है. So that is also okay. So flow of that fluid is involved in that also. So rheology is also involved in the that. So you should know the rheology, the viscosity and all that. Okay, because you can design a instruments. You can decide whether you need a light container, whether you need a heavy container. Okay. Now in case of suspension also. Okay. Now what happens in the suspension? In the suspension, solid particles, they are suspended in the continuous medium, okay, in the dispersion medium. Now dispersion medium in the suspension has a very high viscosity. अगर आपने सस्पेंशन देखा होगा तो उसमें बहुत ज़्यादा विस्कस रहता है, उसमें सस्पेंडेड पार्टिकल्स रहते हैं. एट द रेस्ट वो सस्पेंशन में क्या है, देयर इज अ हायर विस्कोसिटी. नाउ इफ यू ट्राई टू पोर दैट सस्पेंशन, it will not easily get poured. If you shake that suspension bottle and then try to transfer or try to pour, then it is easily pouring. Why? Because just by simply shaking, the rheological properties of that suspension changes. Rheology is very important. Now these coconut oil or groundnut oil, syrup, okay, honey, they are highly viscous and there is the flow. Syrup has a highest internal friction. There is interparticular interaction, and that's why it pours slowly. Now, what do you mean by viscosity? Again, in the another term, it is nothing but the dynamic viscosity or absolute viscosity. So it is calculated as the shear stress, that is the F. Shear stress is denoted by capital word F or force Now it can be either F dash A. Okay? F dash A मतलब force required, force per unit area, force per unit area applied. Stress मतलब stress is denoted by capital word F. It is nothing but the force per unit area applied divided by the rate of shear or velocity gradient. So what is the viscosity? Viscosity is nothing but the stress, that is F divided by the rate of shear. So you can say your here. Okay, viscosity is equal to viscosity eta is equal to F divided by G. What is F? F is nothing but the stress, applied stress. And what is G? It is nothing but the rate of shear or shear rate. Or you can say, you can call it as a velocity gradient. F क्या होता है? F is nothing but the stress. Stress क्या है? Force per unit area. Force per unit area. Okay. And what is G? Velocity gradient. Velocity gradient means that is dv by dr. Change in the distance with respect to time. dv by dr. So velocity is calculated as a shear stress, that is a force per unit area, divided by rate of shear or velocity gradient, which is nothing but the dv by dr. Are you getting? समझ रहे हैं आपको यहाँ तक? Tomorrow also I am going to explain same in different way. Now you can see whatever coefficient of viscosity is nothing but the force per unit area required to maintain a unit difference in the velocity between two parallel layers of the liquid at a 1 centimeter. 3-4 बार definition में हुआ. Now poise is the SI unit. Poise is the SI unit of your viscosity, that is derived from Poiseuille, because Poiseuille has made great contribution in the study of rheology. Now unit is expressed as a centipose. Centipose means what? 10 raised to minus 2 poise. 10 raised to minus 2. 10 raised to minus 2 poise. Now CGS unit of this viscosity is nothing but the time second per centimeter square. Now poise is defined as the shearing force required to produce velocity of 20 meter per second between two parallel planes of the liquid having 1 centimeter square area separated by 1 centimeter distance. Now liquid may be considered as a, it is made from a different layer. Okay? जैसे यहाँ पे देख सकते हो. Now this is a, suppose this one is a first layer, this one is a original liquid. If you apply a stress, now liquid is divided, liquid is considered as made from a different layers. Liquid में ऐसे consider किया जाता है कि ये एक plane है, ये दूसरा plane है, ये plane C है, plane D है, plane E है. मान लीजिए initially कुछ ऐसा है आपका. If you apply a stress, if you apply a force on that, as liquid is made from a different planes, so upon application of stress, it will start to flow. Flow कैसे होगा? Flow will be like this. So initial plane will be displaced from one place to another place. Flow कैसे होगा? यहाँ से वहाँ तक. So that is each plane is divided by a distance known as a dr. Change in the position, that is dv by dr. Change in the position of that plane with respect to distance. Okay, that is nothing but the velocity. That is nothing but the velocity. That is nothing but the viscosity. Okay, so it is nothing but the shearing force required to produce a velocity of 20 meter. 20 meter नहीं कितना है पहले आप 1 centimeter per second. Okay, so it is nothing but the force required to produce velocity of 1 centimeter per second between two parallel planes of liquid having each centimeter square area separated by 1 centimeter distance. Now velocity of viscosities of certain organic solvent. The organic solvent के viscosity at a 28 degrees Celsius. जैसे benzene, benzene has a 5.1, 5.816 millipoise. Then viscosity of toluene is around 3.388 millipoise. Carbon tetrachloride का होता है 8.682 millipoise. Ethanol has a viscosity of 5.354 millipoise. So viscosity of some common gums, viscosity of common liquid at a 293 Kelvin. So ethanol has a 1.2 centipose. Glycerin 1490 centipose. देखो यहाँ पे glycerin का viscosity कितना है? बहुत ज़्यादा है, 1490. It will not easily flow. Water has a viscosity known as a 1.01. Plasma has a viscosity 1.5 at 310 Kelvin. Whole blood has a viscosity of 4. Okay. So few example of body fluids and organic. What is meant by fluidity? है ना, कोई अगर फ्लूइड फ्लो हो रहा है because it has a fluidity. What is meant by fluidity? So fluidity is nothing but the reciprocal of viscosity. Fluidity मतलब है जिस जो if a material is having higher fluidity, it means it can easily flow. जिसका fluidity ज़्यादा है वो easily flow होता है. जिसका fluidity कम है वो easily flow नहीं होता. So fluidity is nothing but the reciprocal of your viscosity. As it question आ चुका है, fluidity is nothing but the reciprocal of viscosity. So obviously fluidity is denoted by the word phi, phi. Fluidity is equal to 1 divided by eta. 1 divided by eta. That is the reciprocal of your viscosity. Fluidity क्या होता है? Reciprocal of viscosity. Now kinematic viscosity is nothing but the fluidity is nothing but the kinematic viscosity is divided by kinematic viscosity is nothing but the viscosity divided by density. Now kinematic viscosity जो डायनेमिक होता है तो वो तो देखा है. Now kinematic viscosity क्या होता है? Viscosity divided by density. Fluidity क्या होता है? 1 by viscosity. That is a reciprocal of viscosity. Now most of the dispersion will not obey Newton's law, so they are known as Newtonian fluid. Now on the basis of viscosity में क्या है देखो, what is viscosity? F by G, F divided by G, N is equal to F by G. Means there is a viscosity is equal to shearing stress divided by rate of shear. Shearing stress divided by rate of shear. So force is equal to force is directly मतलब यहाँ पे एक इक्वेशन होता है, that is a shearing stress is proportional to the shearing rate. Okay, as per the Newton has determined this flow of fluid. So shearing stress is directly proportional to the shearing rate. Okay, so to so proportionality constant is nothing but the viscosity. So proportionality constant जो होता है वो eta की consider किया जाता है, and that's why then viscosity is equal to force divided by, that is F divided by G, that is nothing but the stress divided by shearing rate. Okay, so most of the liquids they obey the Newton's law, and that's why they are known as the Newtonian liquids. But some liquids do not obey the Newtonian law. That is nothing but the so shear stress is proportional to the shearing rate. If you apply a shearing stress to a particular liquid, so shearing rate is or velocity will also increase the proportionally. That is for Newtonian liquid. अगर आपने फोर्स अप्लाई किया तो उसका फ्लो हो रहा है प्रोपोर्शनली, है ना, दैट इज नथिंग बट द न्यूटोनियन लिक्विड. अगर नहीं हो रहा है तो नॉन न्यूटोनियन लिक्विड. Most of the dispersion do not obey the Newton's law, so they are known as a non-Newtonian liquid. Now viscosity is the term, or viscosity is the term to describe the flow of Newtonian liquid. जो Newtonian liquid है which obey Newton's law, so to express them viscosity is the term. So viscosity is the term to describe the flow of Newtonian liquid. Now some liquids or fluids they do not obey the Newton's law. They are known as a non-Newtonian liquids. Means if you apply the stress, they will if you apply the stress, shearing rate will not be increased. Okay, proportionally. Yeah? That is not a non-Newtonian. So for describing the non-Newtonian liquid, apparent viscosity is used. The term apparent viscosity is used to describe the non-Newtonian. Non-Newtonian के लिए apparent viscosity है ना. Newtonian fluid के लिए क्या है? Simply viscosity. Viscosity is for the Newtonian liquid. Newtonian liquid will obey. Okay, increasing the stress will increase the shearing rate proportionally. That is nothing but the Newton's law. Non-Newtonian liquids they will not obey the Newton's law, and to describe them apparent viscosity term is used. So in that first one is nothing but the relative viscosity. Relative viscosity मतलब क्या? It is the ratio of viscosity of dispersion to that of the vehicle. Okay? Means viscosity of dispersion or solid to that of the vehicle viscosity, known as a relative viscosity. So relative viscosity is denoted by eta r. Eta r is equal to n eta divided by eta 0. Eta मतलब it is a viscosity of dispersion and is a viscosity of vehicle. That is a relative viscosity. Now specific viscosity is another term. So what is specific viscosity? Relative increase in the viscosity of dispersion. Relative increase in the viscosity of dispersion over that of the solvent alone. That is specific viscosity. Now specific viscosity is obtained by, ये कैसे पता है specific viscosity? It is obtained by 1 minusing the 1, minusing 1 minus viscosity. Viscosity, तो viscosity ना, viscosity of dispersion ना, जो relative viscosity है ना, उसको 1 से minus करो. So specific viscosity means 1 minus relative viscosity. 1 minus अगर ये करेंगे आप पूरा 1 minus n divided by n 0, 1 minus eta divided by eta 0, we will get this specific viscosity. 1 minus relative viscosity is nothing but the specific viscosity. So specific viscosity is nothing but the viscosity of dispersion over that of the solvent alone. So eta minus eta 0 divided by eta 0, that is the specific viscosity. तो इसके ऊपर क्वेश्चन आते हैं, what is relative viscosity, what is specific viscosity, now what is the reduced viscosity. So specific viscosity divided by its concentration. तो simply जो specific viscosity है ये divided by concentration, that is the reduced viscosity. So remember viscosity is nothing but the denoted by eta. Fluidity is nothing but the reciprocal of viscosity. Kinematic viscosity, you know that. So now for Newtonian liquid, viscosity is the term. For non-Newtonian liquid, apparent viscosity is there. So it is in comparison with the known liquid. So other non-Newtonian liquid, they are compared with known viscosity liquid. Now relative viscosity मतलब क्या है? Ratio of viscosity of dispersion to the solvent or vehicle. So NR, relative viscosity is equal to N divided by N0. Now specific viscosity मतलब क्या है? 1 minus relative viscosity, 1 minus relative viscosity N divided by 1 minus N minus N0 divided by N0. So N eta minus eta 0 divided by eta 0. It is a specific viscosity. Now reduced viscosity means specific viscosity divided by the concentration. So just specific viscosity divided by concentration. So reduced viscosity is equal to specific viscosity divided by concentration. Question आता है इसके ऊपर, what is the relative viscosity, what is the specific viscosity, what is the reduced viscosity. Now another is there known as the intrinsic viscosity. Reduced viscosity of different concentration of substance. If you plot reduced viscosity of different concentration of substance, which is calculated or determined, and it is plotted, and y-intercept, by whatever y-intercept you are going to get, intercept value is known as the intrinsic viscosity, and it is useful in the determination of molecular weight of polymer. So what is the intrinsic viscosity? So it is denoted by simply eta, bracket eta k m raised to a. You have to plot reduced viscosity of different concentration of substance, that is determined and plotted on x-axis and y-axis. So concentration on x-axis and viscosity on y-axis. Right? Now if you extrapolate that concentration under 0, and then you will get a y-intercept. That y-intercept is nothing but the intrinsic viscosity, which is useful in the determination of molecular weight of polymer. Now factors affecting on the viscosity. So intrinsic factor कौन से? So intrinsic factor in that chemical nature of that substance. In molecular weight, higher will be the molecular weight, more will be the viscosity. Molecular weight is directly proportional to the viscosity. ज़्यादा molecular weight होगा, ज़्यादा viscosity होगा. Size and shape. Irregular shaped liquids are viscous than symmetrical shape having globules. Then intermolecular forces, ज़्यादा intermolecular forces है तो ज़्यादा viscous रहेगा. These are the intrinsic factor which affect the viscosity of your liquid. Intrinsic factor क्या है? Chemical nature होता है, molecular weight. जितना molecular weight ज़्यादा उतना viscosity ज़्यादा. Size shape अगर regular है तो viscosity कम रहेगा. Size shape अगर irregular है तो viscosity ज़्यादा रहेगा. Intermolecular forces अगर कम है तो viscosity कम रहेगा. Intermolecular forces ज़्यादा है तो viscosity ज़्यादा रहेगा. Now extrinsic factor which affect the viscosity. So increasing the pressure, increasing the viscosity is there, because increased cohesive force or force of interaction. And viscosity is also increased by small amount of non-electrolyte like sucrose, glycerin. Small amount of strong electrolyte will decrease the viscosity. Factors affecting on the viscosity is the temperature भी होता है. If you increase the temperature, viscosity will be decreased, because temperature is inversely proportional to the viscosity. Next we'll see. So consistency curve or a rheogram. So if you plot a rate of shearing against the shearing stress, or if you plot a rate of shearing against the shearing stress, then Newtonian liquid. So a flow will start from, है ना, न्यूटोनियन लिक्विड का फ्लो कब चालू होगा, जैसे आप स्ट्रेस अप्लाई करोगे, न्यूटोनियन लिक्विड विल स्टार्ट फ्लोइंग. Okay, so if you apply a stress, rate shearing rate will also increase, no, in the proportion, and fluid will begin to flow. So that is for Newtonian liquid. And viscosity of such kind of liquid can be determined by taking any point on the slope. Slope is nothing but the fluidity, and fluidity मिल गया तो viscosity मिल जाएगा आपको. Viscosity is equal to fluidity is equal to 1 upon viscosity. So Newtonian liquid, when you apply stress, so it will get sheared and it will start flowing. So as far as the Newtonian liquids are concerned, so flow will start from the, you know, flow will start from the, for non-Newtonian liquid. Okay, non-Newtonian liquid. Non-Newtonian liquids, they are again further divided into different types like plastic flow, pseudoplastic flow, dilatant flow, etc. etc. Thixotropic, negative thixotropic, etc. etc. Now, what is non-Newtonian fluid? So they will not obey Newton's law. Newton's law क्या होता है? न्यूटन्स लॉ होता है कि जैसे आप स्ट्रेस अप्लाई करते हो, उसी प्रोपोर्शन में शेयर होना चाहिए वो मटेरियल और फ्लो होना चाहिए. But there are certain liquids which are known as the non-Newtonian liquids. When you apply stress to them, so okay, for example, so plastic flow. What do you mean by plastic? Material showing the plastic flow. How they will be there. For example, if you apply stress, okay, so it will not begin to flow. It will take some time. So certain amount of stress is required. Then it will, certain amount of stress is required, which is already required for the flow, which is already required for the material. And if you pass this value, if you pass this stress value, then material will start to flow. Material will start to flow. So this the point from which it is starting, known as a yield value. So yield value is nothing but the force of, it is a force of flocculation. It is known as a force of flocculation. Yield value indicate the force of flocculation. इसमें yield value होता है, that is known as a plastic flow. Okay, now it is plastic flow is given by the suspension, okay? Deflocculated suspension. Flocculated suspension. So flocculated suspension will show the plastic flow. Plastic flow. And that's why the yield value is corresponding to the force of flocculation. Yield value होता है, that is corresponding to the force of, that is corresponding to a force of flocculation. So plastic flow is shown by the, plastic flow is shown by the flocculated suspension. So if you apply stress, it will not begin flow. It will take certain where certain amount of stress is required. Now this stress, okay, then it will start flowing. That certain amount of stress is known as a yield value. So up to the yield value, the material will not start flowing. So once you crosses the yield value, or there is a shearing force, certain amount of shearing force is required, and if you cross that, then only this material will start to flow. है ना. प्लास्टिक का मतलब क्या है? प्लास्टिक कब टूटेगा? अगर आपने थोड़ा सा स्ट्रेस उसको फोर्स दिया, वो जल्दी नहीं टूटेगा. लेकिन उसके अगर इंटरमोलिकुलर फोर्सेस अगर ब्रेक करने वाला इतना फोर्स डाल दिया, तो वो ब्रेक हो जाएगा, है ना. So it will break. So likewise that. So if you increase the shearing stress, so it will take certain shearing stress, and rate of shearing will not be increased. Okay, but up to a certain point, after that, if you increase the stress, rate of shearing will increase proportionally. Now this point is known as a yield value. Yield value indicate the force of flocculation in case of suspension. Flocculated suspension, they will show you plastic flow. Second होता है आपका pseudoplastic flow. Pseudoplastic flow means it is also known as a shear thinning system. Also known as shear thinning system. So it is also ये जो curves है, they are known as a consistency curves or also known as a rheograms. They are also known as a rheograms. Rheograms or consistency curve. Now pseudoplastic flow. Are you able to see the screen? Screen दिसने क्या? Am I audible? Okay. तो यार समझ के लेना है यहाँ पे थोड़ा सा है ना कैसा consistency curves or they are also known as rheograms. So if you rheograms or consistency curve, rheograms or consistency for Newtonian liquid. So if you increase the shearing stress, so rate of shearing is also increased and material or fluid will start to and it will the consistency curve will start from the origin point of origin only. Okay, because in this case shearing stress is proportional to the rate of shearing and fluid will flow. That is a Newtonian flow. The Newtonian liquids will obey the Newton's law. That is a and if you apply stress, shearing rate will increase proportionally. That is a liquid. That is known as a Newtonian law. Or those law is obeyed by Newton's law are obeyed by all Newtonian liquid. For example, water. You know, water. Water is a Newtonian liquid. Okay? Ethanol, like that. Now, non-Newtonian liquids will not obey the law. So, if you apply shearing stress to them, so rate of shearing will not increase proportionally. Okay, it will take certain time. Now this time, okay, in case of plastic flow. So, but this point is known as a yield value. Once you cross the yield value, then material will begin to flow. Now, yield value is nothing but the it is known as a force of flocculation. इसके ऊपर क्वेश्चन आ चुका है. It is known as a force of flocculation in case of flocculated suspension. Now that's why plastic flow is shown by flocculated suspension. Plastic flow is shown by flocculated suspension. यहाँ पे याद रखना है. और इसके बाद में एग्जांपल आएंगे आपको. यहाँ पे थोड़ा समझ लो. फिर नॉन न्यूटन. Then in the non-Newtonian you have pseudoplastic flow. Pseudoplastic flow. So if you apply shearing stress over here, so rate of shearing will not increase proportionally, and the viscosity of liquid will get decreased initially. Viscosity of liquid will get decreased initially. It will decrease initially, and that's why it is known as a shear thinning system. Shear thinning system. Shear thinning system. And now this type of flow is shown by polymer in the solution. Polymer in the solution. जैसे आपका acacia, gelatin, trigant, carboxymethyl cellulose. So these type of material, when you apply a stress over there, so viscosity will decrease. Viscosity will decrease. So pseudoplastic flows is very important in case of suspension. So suspension में क्या होता है? Initially बॉटल में आपका viscous liquid होता है. जब आप उसको शेक करते हो, उसका viscosity कम हो जाता है और easily pour हो जाता है. That is a pseudoplastic flow. Pseudoplastic flow is shown by polymer in the solution. Dilatant flow. Now dilatant flow, in this case, if you apply the shearing stress, rate of shearing will increase not proportionally, not proportionally. So what happens in this system? Here is an increase in the viscosity of liquid. Viscosity increase. If you apply the shearing stress, viscosity of this type of liquid will increase, or volume of this type of liquid will increase. That's why there is a increase in the volume. Here is a decrease in the volume, or here decrease in the viscosity, here increase in the viscosity. तो pseudoplastic flow में जब आप स्ट्रेस अप्लाई करते हो तो उसका वॉल्यूम डिक्रीज हो जाता है और उसका विस्कोसिटी डिक्रीज हो जाता है. इन केस ऑफ डायलेटेंट शेयर अप्लाई किया आपने, ओके, स्ट्रेस अप्लाई किया, यहाँ पे वॉल्यूम बढ़ जाता है ना, वॉल्यूम इज इंक्रीज्ड एंड विस्कोसिटी इज आल्सो इंक्रीज्ड. दैट्स व्हाई इट इज नोन एज अ डायलेटेंट. व्हिच okay, material showing dilatant flow, so that material which is having more than 50% solid content. So suspension having more than 50% solid content, 50% solid content is made. So such kind of suspension will show dilatant flow. Then thixotropy is there. ये अपन बाद में explain करता हूँ. तो temperature is inversely proportional to the viscosity. So increase in the temperature will decrease the viscosity because of the breaking of cohesive bonds between the molecule. Cohesive process between the molecule. So Newton was the first who studied the flow properties. He found that shearing stress is proportional to the rate of shearing, and he taken the proportionality constant known as eta. Now this eta is known as a viscosity. Therefore, viscosity is equal to F divided by G. F divided by. Now rheogram is nothing but the rheogram or consistency curve. जो होता है that will give you relationship between shear stress and shearing rate. If you plot a shearing stress on a x-axis and if you plot a rate of shearing on y-axis, so you will get a curve for particular type of material है ना. कुछ material के लिए आपको क्या आएगा, straight curve आएगा. That is for Newtonian liquid because they obeys the Newton's law. Okay? Rate of when shearing stress is proportional to the rate of shearing, okay, as per this equation, and they are known as Newtonian liquids. So if you apply the stress, rate of shearing will increase proportionally and fluid will begin to flow. Now some liquids they will not obey the law, Newton's law, known as a non-Newtonian liquid. So in that plastic flow, pseudo-plastic flow, dilating flow, thixotropy, negative thixotropy, negative thixotropy, rheopexy is there. So on that part they already asked a lot of times. So इसके ऊपर भी क्वेश्चन आया, Newtonian liquids, Newtonian fluids or Newtonian liquids, they obey the Newton's law. What are the examples of Newtonian? So water, glycerin, chloroform, solution of syrup, very dilute colloidal solution. Now the viscosity term is used to describe the Newtonian liquid. जैसे मैंने बोला है कि Newtonian liquid can be described in terms of viscosity. Water, glycerin, chloroform, solution of syrup, dilute solution of colloids or colloidal solution. They can be adequately described by the viscosity term. That's why they are known as the Newtonian fluids. Non-Newtonian fluids, they will not obey the Newton's law. So example क्या है, heterogeneous dispersion like suspension, emulsion and semi-solid. So they will not obey the Newton's law, and that's why they can be described by apparent viscosity, which is used to describe the non-Newtonian fluid. ठीक है, तो इसके ऊपर क्वेश्चन आ चुका है ऑलरेडी. Following is not a Newtonian fluid. वाटर, ग्लिसरीन, क्लोरोफॉर्म, ये तीन ऑप्शन थे और एक में ऑप्शन था ऑइंटमेंट. ऑइंटमेंट वाज नॉट अ न्यूटोनियन fluid. ऑइंटमेंट मींस सेमी सॉलिड, क्रीम्स, ऑइंटमेंट, पेस्ट, है ना, ये सब आता है इसमें. सस्पेंशन, इमल्शन, नॉन न्यूटोनियन fluid. आर यू गेटिंग? समझ रहा है आपको? इसके ऊपर क्वेश्चन आता है न्यूटोनियन लिक्विड कौन सा है, नॉन न्यूटोनियन लिक्विड कौन सा है. Now what do you mean by plastic flow, non-Newtonian liquid? We have seen the consistency curve. So it will not pass through a origin. This substance initially will behave like an elastic body. So those substances which are showing plastic flow, they will behave like an elastic body initially. Okay? And they will flow when initially the less amount of stress is applied. They will not flow. Will not flow initially. So increase in the stress will lead to non-linear increase in the shear rate, which progressively get lengthless. मतलब अपने देखा है वो consistency curve करिए पहले. So if you apply stress, so it will not, they will resist the flow. They will resist the flow, okay, initially. And once if you break this, the force, okay, the force of flocculation, yield value, एक पर्टिकुलर फोर्स होता है, वहां से आगे जाके वो से आगे स्ट्रेस अप्लाई किया तभी फ्लो हो जाएगा. Behave initially they will be like an elastic body. If you apply stress, there is no flow, there is no increase in the shearing rate proportionally. Once you got after the yield point, if your stress is more than the yield value of that particular suspension, then there is a stress will increase. Stress will if you apply stress beyond the yield value, then what will happen, the shearing rate will also increase proportionally linearly. Right? To describe such a liquid's yield value is nothing but the intersect of x-axis with the linear portion which is extra plotted. जैसे यहाँ से चालू होगा ना, it is nothing but the intersecting. So the point at which it is intersecting known as the yield value, the intersect. Plastic flow can be expressed by the in terms of yield value. इसके ऊपर as it is question आ चुका है. Plastic flow can be expressed in terms of yield value. It is nothing but the force of flocculation. Force of flocculation. Plastic viscosity, okay, there is nothing but the linear portion, then there is a viscosity. So initially it will reach the deformation. Plastic flow is expressed by this yield value, and it is nothing but the force of flocculation in the suspension. Plastic flow is because of the presence of floccules. Plastic flow is because of the presence of flocculated, it is aggregation or floccules of particles in a concentrated suspension. इसमें बटर में भी प्लास्टिक फ्लो होता है, plasters, gels, certain ointments. So remember the examples of material showing plastic. Example is nothing but the flocculated suspension, plasters, gel, and certain ointments. They will show. So yield value is nothing but the stress required to break the interparticular contact. Yield value is nothing but the force or stress required to break the force, okay, to break the interparticular contact of force, so that particle behave individually, which is an indication for flocculation. It's an indicator for flocculation. Okay? याद रखना है प्लास्टिक फ्लो, द मटेरियल विच इज शोइंग प्लास्टिक फ्लो, they can be okay, so they can be expressed by yield value. इसके ऊपर भी क्वेश्चन आ चुका है. What is that? It is nothing but yield value will show you the force of flocculation or force of attraction between two particles. Once you break that force, then particle will behave individually and then it will. So it is indicator of force of flocculation. इसके ऊपर भी क्वेश्चन आ चुका है. Yield value is a indicator of force of flocculation. These material which show you plastic flow, material showing the plastic flow, they are known as the Bingham bodies. इसके ऊपर GPAT 2023 में क्वेश्चन है. Material showing the plastic flow are also known as Bingham bodies. Yield value will be higher in the flocculated suspension and will be nil in the deflocculated suspension. मतलब अगर flocculated suspension है तो उसमें yield value ज़्यादा रहेगा, अगर flocculated नहीं है या deflocculated है so yield value will be nil, मतलब zero. Plastic flow समझ में आया आपको? Yes or no? Plastic flow समझ में आ लगा? Now pseudoplastic flow. We have seen the consistency curve, so in that you are going to get a different type of curve. Pseudoplastic flow will start in the origin only near at a zero stress. Increasing the shear stress increases the shear rate proportionally, and it cannot be expressed by a single value. The material which are known as a pseudoplastic, their flow start from the point of origin when stress is zero. If you increase the stress, the shear rate will increase proportionally, but it cannot be expressed by a single value. And for that, there is one equation. It can be expressed by this equation: F raised to n eta g. F raised to n eta g. Now, in the pseudoplastic flow, the n is more than 1. N is greater than 1. The value of n is greater than 1. In the pseudoplastic flow, greater will be the okay, greater will be the value of n, greater will be the pseudoplastic behavior of material. If n becomes 1, that is a if n value becomes 1, that is a plastic flow. So for pseudoplastic, n should be more than 1. For plastic, n is equal to 1. Okay, and there is one more. I think n is equal to 0 for Newtonian liquid. So n is equal to 0 for Newtonian liquid. 0 for Newtonian liquid, more than 1 pseudoplastic, it equal to 1 plastic. Now pseudoplastic flow is shown by polymer dispersion. Example, triacanthi. So okay, then sodium arginate, methyl cellulose, sodium carboxyl methyl cellulose in the water. Pseudoplastic flow कौन दिखाता है? क्वेश्चन इसके ऊपर भी आ चुका है. Pseudoplastic flow is shown by the polymer in the solution. या ये ही टर्म याद रखो, polymer in the solution. पॉलीमर कौन है? ट्राइकांत क्या है? पॉलीमर है. सोडियम आर्जिनेट पॉलीमर है. मिथाइल सेलुलोज पॉलीमर है. पॉलीमर है ना. सो न्यूटोनियन लिक्विड्स है ना, ग्लिसरीन, वाटर है ना, कोलाइडल सॉल्यूशन है ना, अल्कोहल. देन मटेरियल शोइंग प्लास्टिक फ्लो, प्लेटेड सस्पेंशन, concentrated suspension, paints, gels है ना. in pseudoplastic flow, polymer in the solution like tricant, sodium alginate, methyl cellulose, सोडियम कार्बोक्सिल methyl cellulose in water. तो ये याद रखना है. इसके ऊपर बहुत बार क्वेश्चन आकर कि concentrated suspension will show following type of rheological behavior. उसमें ऑप्शन में आता है न्यूटोनियन behavior, ऑप्शन बी प्लास्टिक फ्लो, ऑप्शन सी pseudoplastic flow, ऑप्शन डी dilatant flow. So you should know ना. तो सस्पेंशन में दो टाइप का फ्लो आता है. पहला आता है plastic flow. If plastic flow is if suspension is flocculated and concentrated, it is a suspension containing more than 50% solid, then you will get a dilatant flow. याद रखना pseudoplastic flow मतलब क्या है? Pseudoplastic flow, the flow curve or rheogram will start from the zero or origin. If you increase the stress, sharing rate will also be increased, but it cannot be expressed by single value. And two such kind of liquids they are expressed by this equation F raised to n. So n in the pseudoplastic flow, n is more than one. If it is one, then it is a plastic flow. If it is zero, then it is nothing but the Newtonian liquid. Okay. Pseudoplastic flow is shown by polymer in the solution like gelatin, okay, triacantha alginate, sodium carboxymethyl cellulose and methyl cellulose. Now next होता है dilatant flow. Now dilatant flow is nothing but the again we have seen the consistency curve. Now with increase in the shear rate, there is an increase in the resistance to flow. If you increase the shear to the material showing dilatancy, so there is increase in the volume because of the applied shear stress in this system. Apply the shearing way. If you apply the stress, so it will resist the flow and there is an increase in the volume or increase in the viscosity of simply of the liquid. So what will happen? Increase in the viscosity. That's why dilatancy volume बड़ा था क्या हुआ है फैल गया ना dilatancy. That's why it is known as a dilatant. And remember pseudoplastic, okay, pseudoplastic flow material showing pseudoplastic flow, they are known as a shear thinning system. Shear thinning system. Material which show plastic flow, pseudoplastic flow, they are known as a shear thinning system. And material which show dilatant flow, they are known as a shear thickening system. Shear thickening system is the good question. Because increase the apparent viscosity at a higher shear rates. आपने अगर यहाँ पे फोर्स अप्लाई किया तो यहाँ पे विस्कोसिटी क्या होगा बढ़ जाएगा उसका. That is known as a dilatant flow. Now this dilatant flow is okay shown by a suspension having 50% solid, more than 50% solid. तो 50% से ज़्यादा solid है suspension में तो वो क्या दिखाता है आपको dilatant flow दिखाता है, right? Now for there is one equation. So in the plastic flow is shown by flocculated suspension. You have to remember butter, plasters, gel and certain ointments. Okay, plastic flow, right? Then pseudoplastic flow, pseudoplastic flow is shown by polymer in the solution. Okay, polymer in the solution like triacanth, sodium alginate, methyl cellulose, etc. etc. And dilatant flow is shown by the concentrated suspension. It is shown by the concentrated suspension. So pseudoplastic flow is known as shear thinning system because if you apply the stress in the pseudoplastic flow, there is a decrease in the viscosity or there is decrease in the volume. That's why pseudoplastic, the material which is showing pseudoplastic flow, that is known as a shear thinning system. Shear thinning system बोलते हैं इनको. And material showing dilatant flow, it is known as a shear thickening system. Dilatant system में क्या होता है कि if you apply stress, there is increase in the volume as well as viscosity of material. That's why it is known as shear thickening system. Okay. So equation F raised to n equal to eta g. N is less than 1 here. In case of dilatant, n is less than 1. Decrease in the degree of dilation increase. जितना कम होगा उतना dilatancy बढ़ जाएगा. Dilatant flow is shown by the suspension which are having high concentrated solids. Dilatant flow is shown by suspension with a high concentration of solid. So more than 50% and solid अगर है, if suspension has a more than 50% solid, that will show a dilatant flow. Suspension of starch in the water, dilatant flow. 12% suspension of kaolin, dilatant flow. 30% zinc oxide in the water suspension. मतलब क्या है कि dilatant flow जो है ना वो कौन दिखाता है सस्पेंशन हैविंग मोर देन 50% सॉलिड और स्टार्च सस्पेंशन इन द वाटर, देन 12% kaolin सस्पेंशन इन द वाटर, 30% जिंक ऑक्साइड इन द वाटर. सो दीज सस्पेंशन के रिगार्डिंग दो फ्लो है. सस्पेंशन के रिगार्डिंग दो फ्लो है. एक होता है फ्लॉकुलेटेड सस्पेंशन है ना, दे विल शो यू प्लास्टिक फ्लो. will show you plastic, because plastic flow में क्या आता है, yield value आता है, yield value. Yield value क्या है, indicator of force of flocculation. So in the plastic flow there is a yield value and which is nothing but the force of flocculation. So इससे आप यहाँ पे थोड़ा सा याद रख सकते हो कि plastic flow that is shown by flocculated suspension, some gels, okay, then paints and etc. Okay. Then pseudoplastic flow is shown by the polymer in the solution, okay, like sodium alginate, tragacanth, and methyl cellulose, then carboxymethyl cellulose. In dilatant flow is shown by the concentrated suspension, more than 50% solid content. Starch in a water. Question आता है इसके ऊपर. Starch suspension in the water will show following type of rheological behavior. Kaolin, 12% kaolin in the water, 30% zinc in the zinc oxide in the water. That will show you dilatant flow. Dilatant flow. Dilatancy. Dilatancy means shear thickening system. Pseudoplastic flow means shear thinning system. याद रखना है. Sediment in case of deep flocculated suspension is a dilatant and will resist the any attempt of stirring and shaking. This effect is called as a caking or claying. Sediment जो बनता है suspension में sediment in the deep flocculated suspension. Sediment in the deep flocculated suspension is a dilatant and it will resist any attempt of stirring. अगर जो सस्पेंशन में है ना नीचे जो सेडिमेंट बना है ना, वो एकदम ऐसा टाइट सेडिमेंट बनता है और उसमें अगर आपने शेकिंग करने का ट्राई किया तो वो डिफ्यूज नहीं होता है. ओके, दैट विल रेजिस्ट द स्टरिंग एंड दैट इज नोन एज अ क्लेइंग और केकिंग ऑफ सस्पेंशन. देन थिक्सोट्रॉपी, थिक्सोट्रॉपी होता है. नेक्स्ट फिनोमेनन इज द थिक्सोट्रॉपी. When shear thinning system is agitated and kept aside, when shear thinning system मतलब pseudoplastic flow, when material showing pseudoplastic flow, they are agitated मतलब they are stirred and kept aside, return to its original state of purity, but it will take a time, it will take a long time to recover as compared to time of agitation. This behavior is known as a thixotropy. So what is thixotropy? A isothermal and comparatively slow recovery on the standing of material of which consistency is lost by shearing. मतलब क्या, जो shear thinning system है pseudoplastic material जो है, the material which is showing pseudoplastic flow, नॉर्मली जो मटेरियल है उसका जो फ्लूइडिटी है, वो फ्लूइडिटी जो है वो उसके बाद में आपने उसे स्टर किया आपने मान लीजिए कुछ 10 सेकंड के लिए, तो उसका जो करने के बाद में जो आपने स्टर किया मतलब क्या शेयरिंग स्ट्रेस अप्लाई किया, तो वहाँ पे रेट ऑफ शेयरिंग भी बढ़ जाएगा. और ये क्या है, शेयर थिनिंग सिस्टम है, वो विस्कोसिटी कम हो जाएगा, वो फ्लो बढ़ जाएगा उसका. बट अगर आपने स्टॉप किया तो मटेरियल ने क्या करना चाहिए कि इमीडिएटली उसमें ओरिजिनल फ्लूइडिटी में आना चाहिए. ओके, सो कंसिस्टेंसी ऑफ मटेरियल व्हिच इज लॉस्ट ड्यू टू द शेयरिंग स्ट्रेस or due to the agitation or stirring. Now material should return to its original state of fluidity within a particular time. Okay? But if that time is more than the stirring time, this behavior is known as a thixotropic behavior. This behavior is known as a thixotropic behavior. Now thixotropy is nothing but the isothermal and comparatively slow recovery of a standing material of which consistency is lost by shearing, known as a thixotropy. तो याद रखना है उसका थिक्सोट्रॉपी में क्या होता है. सो जो शेयर थिनिंग सिस्टम होता है pseudoplastic flow वाले मटेरियल, सो इफ यू अप्लाई स्ट्रेस एंड इफ यू कीप देम ना, जैसे मान लीजिए सोडियम कार्बोक्सिमेथाइल सेलुलोज का सॉल्यूशन है, अभी सॉल्यूशन बना के कल बनाया आपने आज रखा है, अभी उसका जो फ्लूइडिटी है वो एक पर्टिकुलर फ्लूइडिटी है उसका. अगर आपने उसमें स्टर किया है ना, स्टर किया मान लीजिए आपने स्टर किया 5 सेकंड 10 सेकंड के लिए, ओरिजिनल जो फ्लूइडिटी है उसका वो, और आपने स्टर किया 10 सेकंड के लिए, तो स्टर करने के बाद में उसका विस्कोसिटी कम हो जाएगा. पहले का जो फ्लूइडिटी था वो और अभी डिफरेंट हो गया, बट वो आपने स्टरिंग बंद किया, उसके बाद में उसको रिटर्न स्टेट में आने के लिए वॉट एवर ओरिजिनल फ्लूइडिटी वॉज देयर, सो टू गेट रिटर्न स्टेट ऑफ द फ्लूइडिटी इट विल टेक अ लॉन्गर टाइम एज कम्पेयर टू द टाइम ऑफ स्टरिंग. आपने 5 सेकंड स्टर किया था लेकिन उसने 10 सेकंड लिया to recover back to the fluidity. Now this behavior of the liquid is known as a thixotropy. Okay, it's known as a thixotropy. Now it is defined as the isothermal and comparatively slow recovery on the standing material of which consistency is lost through shearing. Now याद रखना एक क्वेश्चन आ चुका है इसके ऊपर. Thixotropy is nothing but the gel, sol, gel, the material which is showing thixotropy. है ना, जो मटेरियल थिक्सोटॉपिक बिहेवियर दिखाता है वो ओरिजिनली है ना, ओरिजिनली जेल स्टेट में आता है. सो इट इज इन अ जेल स्टेट. जेल मतलब क्या है? जेल मतलब हायर विस्कोसिटी. सो मटेरियल शोइंग द थिक्सोटॉपिक बिहेवियर ओरिजिनली दे आर इन अ जेल स्टेट. मतलब यहाँ पे क्या है, विस्कोसिटी बहुत ज्यादा है. विस्कोसिटी क्या है? बहुत ज्यादा हायर विस्कोसिटी. इफ यू अप्लाई स्ट्रेस, ने स्ट्रेस अप्लाई किया तो ये जो जेल है उसका बन जाएगा. क्यों? बिकॉज व्हाट इज दिस शेयर थिनिंग सिस्टम. स्यूडोप्लास्टिक फ्लो वाले जो होते हैं तो जैसे आप स्ट्रेस अप्लाई करोगे तो उसका विस्कोसिटी कम होगा या वॉल्यूम कम होगा. सो जेल टू सोल, एंड आपने अगर स्ट्रेस रिमूव किया सो अगेन इट विल बिकम अ जेल, बट इट विल टेक अ लॉन्गर टाइम टू बिकम अ जेल. दैट्स व्हाई known as a thixotopic. Slow and comparatively, isothermal and comparatively slow recovery on standing of material of which consistency is lost by shearing. ठीक है. So thixotropy is nothing but gel, sol, gel phenomenon. है ना. जेल है, पहले पहले तो जेल कंसिस्टेंसी का है, उसमें अगर आपने स्टर किया तो वो बन जाएगा सोल्यूशन. ठीक है. और वो आपने स्टरिंग बंद किया वो फिर से वापस क्या बन जाएगा? जेल. दैट्स व्हाई जेल, सोल, जेल. So gel, sol, gel, transforming phenomenon. इसके ऊपर क्वेश्चन आ चुके हैं. Thixotropy is nothing but the gel, sol, gel, transforming phenomenon. क्वेश्चन इसके ऊपर आ चुके हैं. जेल, सोल, जेल 3 बार बोल रहा हूँ. कल भी और एक बार लूंगा मैं, क्योंकि इसके ऊपर बहुत बार क्वेश्चन आता है. कल भी मैं लूंगा. ठीक है. Thixotropy is a gel, sol, gel, transforming phenomena. Shear thinning system. Okay. तो क्या होता है? जेल इट इज अ रेस्ट, एट द रेस्ट इट इज अ जेल. शेयर थिनिंग सिस्टम जो होता है, मान लीजिए एट द रेस्ट जेल इज एट द रेस्ट. ओके. हाई विस्कोसिटी एंड मल्टी पॉइंट कांटेक्ट इज देयर इन केस ऑफ जेल. व्हेन यू अप्लाई अ शेयर, मतलब व्हेन यू अप्लाई फोर्स, सो इट विल बिकम अ सोल. सोल में क्या होता है? लो विस्कोसिटी एंड ओके, लो विस्कोसिटी एंड अपॉन रिमूवल ऑफ स्ट्रेस अगेन इट विल बिकम अ जेल. Then particle contact will be established due to Brownian motion and will have a high viscosity. So gel, sol, gel, that is known as a thixotropic behavior. अब ये thixotropic gel, sol, gel है तो उसके एंटी thixotropic क्या होगा? एंटी thixotropic क्या होगा? सोल, जेल, सोल. उसके ऊपर भी क्वेश्चन आता है. नेगेटिव thixotropic. नेगेटिव thixotropic पहले bulges. If you if you take a concentrated aqueous suspension of bentonite 10 to 15 concentrated aqueous solution of bentonite, you will get a particular type of rheogram. It is known as a hysteresis loop. It is a characteristic bulge in upper curve. दिखा रहा आपको. If you take a concentrated solution of aqueous bentonite 10 to 15%, if you plot the rheogram when shearing stress versus rate of shearing, so you will get a curve like this. Thixotropic material showing bulge. So bentonite magma 10 to 15%, 15% in H2. So how? So if you apply stress, shearing rate will also increase. This is not up curve. ये up curve होता है, ये down curve होता है. So if you apply shearing stress, it will initially will not begin to flow, but after a certain points, yield value के बाद में it will try to flow, and it will then so it will show a curve like this. It will show a curve like this. So this is known as up curve. This is known as down curve. ये down curve है, ये up curve है. So in the up curve of bentonite magma 10 to 15% solution in the water, so it will produce a characteristic hysteresis loop. Hysteresis मतलब एक bulge आएगा, bulging out हो जाएगा. Then recovery उसका state होगा. So it will not superimpose. So up curve and down curve will not superimpose. Okay. So this is known as a bulge. Okay, bulge. Now bulge and spur both are shown by thixotropic material. So bentonite magma will show bulge, and procaine penicillin will show spur. Now spur means procaine penicillin gel will possess a rheogram where bulge curve may actually develop in a spur like position. मतलब ये 2-3 बार bulging रिकवरी होता है, that is poor. Now negative thixotropy means also known as anti-thixotropy. Negative thixotropy is also known as anti-thixotropy. Negative thixotropy is also known as anti-thixotropy. Increase in the consistency on a curve, down curve. Magnesium magna shows increased resistance to the flow when increased time of shear as compared to the resting state. जो thixotropy था, that was a gel sol gel phenomena, but negative thixotropy is nothing but the, so in negative thixotropy, material showing negative thixotropy, they are a solution at a rest, they are a sol at a rest, and if you apply stress, so it will get converted to gel, and if you remove the stress, it will convert it again into sol. So here सोल जेल सोल फिनोमेना है ना, जैसे थिक्सोटॉपी में क्या होता है, जेल सोल जेल फिनोमेना, इसके अपोजिट है सोल जेल सोल फिनोमेना, एंड दैट्स व्हाई इट इज नोन एज अ नेगेटिव थिक्सोटॉपी और एंटी थिक्सोटॉपी. नाउ इट इज सीन इन द फ्लोकुलेटेड सिस्टम कंटेनिंग लो सॉलिड कंटेंट. देखो यहाँ पे और एक बार आ गया सस्पेंशन. फ्लोकुलेटेड सस्पेंशन विल शो प्लास्टिक फ्लो. Flocculated suspension with a low solid content 1 to 10% will show negative thixotropy. इसके ऊपर भी क्वेश्चन आ चुके हैं दो तीन बार. Now rheopexy. What do you mean by rheopexy? The phenomenon in which solution transform into gel state more rapidly, just gently by shaking upon application of low shear rate, keeping in the sol state. Rheopexy मतलब क्या? Transformation of sol to gel just by applying a small stress or just by shaking. कुछ मटेरियल होते हैं जैसे थोड़ा भी शेक किया उसको सॉल्यूशन जो है ना जेल में हो जाए. सोल इज ट्रांसफॉर्म टू जेल नजर यूपेक्सी. इसके ऊपर जीपैट 2021 में क्वेश्चन आ चुका है. नेगेटिव थिक्सोटॉपी में 20 में क्वेश्चन आ चुका है. बहुत बार क्वेश्चन आ चुके हैं. थिक्सोटॉपी, यूपेक्सी, बाद में विस्कोमीटर से. तो विल सी टुमारो अगेन.